So in this problem, we have two figure skaters, an 82 kilogram male and a 48 kilogram female, and they're gliding at the same speed. So if they, again, this will be like firing, because if they were going at, if they were started from rest, you'd pretty much get a similar type problem where one will go in one direction and one will go back in the opposite direction. But they're starting with a momentum, both of them, in the forward direction. So if I use, so we'll say male and female. So the mass of the male is given as 82 kilograms. The mass of the female is given as 48 kilograms. Now, both of them, the velocity of the male and the velocity of the female, have a common velocity. So again, like I said, it's almost like an inelastic collision in reverse. Because in an inelastic collision, after the collision, they have a common velocity. In this problem, before collision, they have a common velocity. So we're going to have, both of them are going to have, they're moving at 7.4 meters per second. And what I wrote there as VM and VF, I could have just written a common V, because they have the same thing. And then it says, the male skater tosses the female forward with a speed of 8.6. So the velocity of the female after being thrown is going up to 8.6 meters per second. So the male, if the female is gaining velocity, meaning the female is gaining momentum, the male has to lose momentum. So the velocity, so we have the velocity of the male after he throws the female. So that's our unknown. So those are your facts. I can use my conservation of momentum equation. So in this one, we're going to get mass of the male, velocity of the male, plus mass of the female, velocity of the female. For some reason I'm using capital letters for female and lowercase for the male. Mass of the male, velocity of the male, and mass of the female, velocity of the female after. So there's my equation. Nothing's zero, so nothing cancels out. So I have to, if I'm solving for the velocity of the male after collision, I'm going to move this term over to the other side and then divide by that. That will get me this by itself. So when all of that is done, the velocity of the male after the throwing, after he throws his partner, is going to be the mass of the male, velocity of the male, plus mass of the female, velocity of the female. Now we're going to move this term to the other side, so that's going to be negative on the other side. So it's going to be minus mass of the female, velocity of the female after. And then that's going to be divided by the mass of the male. And so plugging in the numbers, and hopefully we'll come up with the right answer. We're going to have 6 parentheses. All divided by 1. So the mass of the male is 82 kilograms, so I can put that there and down here. The mass of the female is 48, so that's going to go there, and that's going to go over here. The velocity of the male to begin with is 7.4 meters per second. The velocity of the female to begin is 7.4 meters per second. The velocity of the female after is 8.6. And so now just solving that, and hopefully you'll get the answer that I gave. And I gave the answer for that 6.7. All right, any questions with that? So they're all done, very similar, even though,